Hello guys, welcome to another episode of Xa Talk Show. Today we are going to do Advent of Code 2023, Day 5. Okay, let's begin. Now I'm going to try to be very focused. The focus is to finish the code. Don't worry about efficiency, don't worry about the best elegant code. And I'm going to code it in Wolfram language, which by default is going to be the shortest code of all languages, okay, except APL, because in APL, every function is one single character. So if you count the shortest by number of characters, then nothing beats APL. But the more proper counting of shortest code is you count the tokens. So in APL, each function name is one single character, and but if you count tokens, that's one single token. And in Wolfram language, then usually they have long function names, 10 or 20 characters. But now it's just one token. So if you count by tokens as the shortest code, then Wolfram language will beat APL. It will beat every language, okay? But anyway, I'm going to try to focus on day 5, finish problem part 1 and part 2. My keyboard, this is Kinesis 360 USB version, okay? And this is Ultimate Hacking Keyboard. Fantastic. I recommend it. Go to my Xali keyboard blog website. You'll see video reviews and full review, okay? So let's begin coding. So let's switch to the, so focus on solving the problem, okay? I'm just gonna demo Wolfram language, solving the problem. Okay, so let's begin. If you are here, say hi, okay? I love to see your comments. Don't like just hide in the background, say nothing, okay? Start a code, wait. So the pink window shows all my command names and function calls in Emacs, okay? So you can see command names and keyboard shortcuts. Okay, I'm using a Vorak keyboard and I'm using XaFly keys, which is a modal key binding for Emacs, okay? Let's begin. Wolfram language code, pop it out, so there it is. So let's read problem Advent of Code day 4. Let's start to read the problem. So day 5, not day 4. So go back, Advent of Code, day, oh God, 4, what the fuck is this, 23, 25, okay, day 5, okay, weird way of arranging, okay, focus on solving it within 2 hours, okay. In my line, you could just pass functions to other functions and return functions. There are also anonymous functions that can pass to or return functions. Yeah? What do you mean? Of course, in functional programming languages, you can always do that. Functions return as a function, as an expression, and you can pass that as argument to other functions. That's what functional programming means. Okay, so day 5, okay? Okay. Okay, let's see if I can finish it. Again, I'm gonna try to finish it, so I'm gonna skip reading and all that. Okay. You take the boat and find the gardener right there where they told you would be. Managing a giant garden that looks more to you like a farm. You take the boat and find the gardener right where you were told he would be. Managing a giant garden that looks more to you like a farm. Okay. A water source, island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. Sure, we'll get more sand soon. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? Now, you barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest island, Almanac, just arrived and we're having trouble making sense of it. The Almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. Okay, so you got seed, you got fertilizer, you got soil, and you got water. In what order? Seed, then type of seed. Each type of seed has a type of soil to go with. Each type of soil has a type of fertilizer to go with, and each type of fertilizer has a type of water to go with it. Okay, so it's a hierarchy, it's a tree, beginning with many seeds, type of seeds, soil, fertilizer, water. Okay, so for example, can you see the puzzle? Okay, so you need to move this here. Okay, so for example, seed. Okay, so here is your input probably. Let's copy it. Okay, so here is the input, I guess. So for example, seed 7, 9, 14, 55, 13. Seed to oil map 50, 98, 2, 52, 50, 48. This is seed to oil map. Okay. Seed to oil to soil map. Now you have seeds 79, 14, 55, 13. So how do you make sense of this map? It's got many numbers that's not in the seed, except 50, 98, 2. None of the numbers are in the seed. How does this map work? I don't know. So you got the seed to soil map. Then you got soil to fertilizer map. Okay, strange numbers. Then you got fertilizer to water map. Okay, a bunch of numbers. And the water to light map. Okay, it didn't mention light before in the story. So this water, different water needs different light. Fucking elf land. Then you have light to temperature map. So you have this tree hierarchy. Okay, then you have temperature to humidity map. Okay, then you have humidity to location map. Okay, the almanac starts by listing which seed needs to be planted. Seeds 79, 14, 55, 13. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category, right? That's what map means, okay? That is, the section that starts with seed to soil map describes how to convert a seed number, the source, to a soil number, the destination. That's right. Okay. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Right? Obvious. Okay. But how do you interpret the map list of numbers? So rather than list every source number and its corresponding destination number one by one, the map describes entire range of numbers that can be converted. Okay, so this is a funky map. Typically a map is like 1-to-1 correspondence, clear. But this one is a funky map, so it lists range instead. So each line within a map contains 3 numbers. Okay, the destination range start, the source range start, and the range length. Okay, let's see. So here's a map. So 50 is the let's see, the destination range start, the source range start. So in reverse order, it begin with destination range start, then the source range start, then the range length. So the destination range start, which is 50, that means the soil number begin with 50 to something, and the seed number begin with 98 to something, and the range is 2. Okay, so that means 50 to 52, 98 to 100. So okay, so 50 to 52, this is the soil. 98 to 100, this is the seed to soil map. Okay, very strange. Consider again the example seed to oil map. 50, 58, 98, 2. Then 52, 50, 48. Okay, so how do you interpret 52, 50, 48? So that means the soil begin with 58, then 48 of them. Okay, 52 to to something 100. That's a soil. Then the source, the seed, is 50 to 98. Okay, something like, okay. Then it says the first line has a destination range start of 50. Okay, a source range start of 98, correct, and the range length of 2. This line means that the source range start at 98 and contains 2 values, 98 and 99, right? And the destination range is the same length, but it starts at 50. So its 2 values are 50 and 51, correct? With this information, you know that seed number 98 corresponds to soil number 50. That's right. Okay, and that seed number 99 corresponds to soil number 51. Yeah. Okay, yeah, so the second line means that the source range starts at 50 and contains 48 values. This corresponds to destination range starting at 52 and also contain 48 values. Seed number 53 corresponds to serial number 55. That's correct. Okay, so far, yeah, I understand it. Any source number that aren't mapped corresponds to the same destination number. Okay, so if a seed number is not in this, this silly map defined by a range, then that seed number corresponds to itself, the number in the soil. Okay, the seed number ID corresponds to the same ID in the soil ID. Okay, so if it's not there, it's the same number. Okay, understanding the problem. Any source number that aren't mapped. Okay, yeah. So seed number 10 corresponds to soil number 10 because the number 10 is not in this map. Okay, so the entire list of seed numbers and their corresponding serial number is like that. Yeah, this is a traditional map. So seed and soil. So we first job is to convert this idiotic range map to a standard map. Okay, so you can do a hash table on that, or a list of pairs. So with this map, you can look up soil number required for each initial seed number. Blah blah blah. Okay, I assume I understand it already. The gardener and his team want to get started as soon as possible. So they would like to know the closest location that needs a seed. What? Using these maps, find the lowest location number that corresponds to any of the initial seeds. What? Where is the location? So we got seed to soil, soil to fertilizer, fertilizer to water, water to light, light to temperature. Oh, temperature to humidity, then humidity to location. Okay, so you are giving a seed number ID. You go through these maps, eventually you'll get a corresponding location ID, which is a number. And it's asking, what is it asking? Find the lowest location number that corresponds to any of the initial seeds. Okay, so from a mathematician's point of view, you say that you want to find the minimum. So given a bunch of seeds, each one automatically corresponds to a number, that is the location number. Identify the smallest one, then the answer is that particular seed with that location. Yeah, so the location implies some kind of mile, like distance. They want the nearest. Okay. So the lowest location number that corresponds to any of the initial seeds. To do this, you need to convert each seed number through other categories until you can find its corresponding location number. In this example, blah, blah, blah. I can skip that because I presume I already understand it. I don't need to double check. It's kind of tedious to double check each one. So the lowest location number in this example is 35. Okay, so the answer is 35. So, okay, now this time the input is not just one single text file. It's kind of this jumbled mess. Okay, so you just hard code it. Yeah, I suppose you can. So what is the lowest location number that corresponds to any of the initial seed number? Okay, problem understood. Let's begin coding it. Let me read the comments. Hi. Quintet, hi. M, hi. Thiago S says, hello, Kasa. Hi. M says, well, you have two pair of glasses, okay? One is nearsighted, one is old age magnifying reading glass, okay? So it's already 20 minutes, okay? Now I understand the problem. Let's begin coding. So a bunch of maps. So they are, I can just manually transform this bunch of numbers to the Wolfram language hash table. No, you cannot do it because it's a range, so you need to do some coding. But anyway, so the input, this stupid problem. Okay, so how do you, you can pass the input, but if you treat the input as just one text file, then you need to do a lot of parsing. As I said, the advent of code doesn't care. They don't care about elegance or completeness. They just care about the answer. So the fastest way is let's see. Okay, let me start to code this. So you want to convert this to some sort of input, basically hard-coded it. And for example, we can, say this map 1 equals to, actually there's two of them. So each map you have several range, okay? So you have several range. Each map you have several range. Yeah, what a fucking idiotic. Well, that's coding, right? That's what coding means. Yeah, but now the problem is naming of things. How do you name this? So each map you have a list of range. So one way you can do is that since it's a list of range, you just do like that, okay? Manually convert the input. Yeah, maybe that's it. Yeah, this is a stupid kind of. Okay, so first of all, let's copy the text input. So in this case, the text input is actually, let's put the text input into a it's just copy their original input. Then we create our kind of copy that. Then we create our, okay, let's just do it manually, okay? So map 1. So actually it would be better if you just have list of lists, okay? So seeds. Okay, let me just type it quickly. Okay. E max power. It's wrong. Okay, define a macro. Then apply the macro. Apply the macro. Okay, now we need to replace space by comma space. So we get Wolfram syntax for list, okay? Okay, there's too many. Let's do a regular expression. Regular expression. Okay, we want to copy 0 to 9 space 0 to 9. Okay, that's number space number. Okay, now replace that by the first occurrence, the first capture, comma space, the second capture. Okay, do it. Yeah, do it now. Just fucking stupid. Okay, let's do it again. Okay, that's kind of our input, but wait, there's more. So yeah, so we need to group these two together. Okay. Okay. Okay, then you need a comma after the last bracket. No, no, yes, actually no, yes, yes, yes. No, actually there's a simpler way, but anyway, let's keep going. No, no, yes, no, no, yes, yes, no, no, yes, no, no, yes. Okay, so it's kind of this is the problem. Actually, so we have okay, so let me show you the final result. The final result is like that, okay? Okay, that's clear. Maps, okay? That's kind of your map. Let's see if we got the input valid. You know, we can just paste in Wolfram language, paste it, evaluate, correct. Okay, there's a null, so that you got an extra comma here. In Wolfram language, you cannot have extra comma in a list. In JavaScript, you can. But in Wolfram language, you cannot have the, extraneous comma. If you do, then that means you got an extra element of null, okay? So anyway, so let's double check it's correct. So we got this bunch of maps. Okay, let's see if that's, yeah, that's good. So we got a bunch of maps. Now for each one, for example, this is one of the map. You want to convert it into actual map. So this is a kind of exercise in constructing hash tables or dictionary, and an exercise of sequentially get the value of hash table, okay? Are you an EO? Are you a what? Hi, Xa. Okay, so far so good. So we got one of the map like that, defined by a range. Now we want to convert this into an actual hash table, into an actual dictionary. In Wolfram language, it's called association. Okay, so given this input, you want to turn this into okay, range 2. So let's see, for example, this one. For example, 52, you want to turn it tedious. Yeah, there's a problem. It's just tediousness. That's coding exercise. So 50. Let's see how we do this. 2. So begin and so you write a function that, so each line is a partial map. So each line defines a partial map. What if they overlap? That's the thing. You see, that's a tricky thing. When you have a range, another range, what if they overlap? You see, that's the tricky thing of advent of code. In the actual puzzle, then you pop up such an example. So what if you have overlap in the range? Well, in that case, I presume the second ones override the previous. No, the question to Q intent, Agda, no. Okay, so the answer to Q intent. Have you programmed Agda? Okay, so range, so you 98, so 2 elements. How do you generate this? We just want to get this done. Okay, don't worry about efficiency or anything. So a range of 2 elements, 50. Basically, you want this, okay? Something like that. Okay, let's see. Actually 52 elements, so 50 and 51 minus, you don't, so you actually need to minus 1 here. Okay, so let's see. So let's work on one of the range first. Okay, here is a function. The source and destination. So first of all, the function source. The source is the second part. So this is a function notation for the second argument, which is the 98, because we want to begin with source. Okay, so the source map to not map yet. So we start a range. So we want to call range, and the source will be that. Okay, then a range, then then that plus 2 minus 1. Well, plus 2, the 2 came from the third argument there. So here the plus 2 should be the third argument. Okay, second argument plus the third argument, then minus 1. That is the range of the source. Okay, now for the range of the destination, it's similar. Okay, so the destination is the first element, and then the first element, okay, plus the third element, okay, and also minus 1. Okay, so here we got an explicit list of numbers in the source. Okay, and this one is an explicit list of numbers in a destination. Okay, and so once we got that, let me show you. Okay, so we just make them into a list, and let's do transpose, not translate, transpose. Okay, we just gonna transpose this list. So instead of one row of ID and second row of ID, we transpose it, so it becomes, each row becomes a pair. The first element is the source ID, the second element is the destination ID. Okay, so that's what transpose, that's like transpose of a matrix. Okay, so now this thing is a function. Okay, so this thing is a function. Now this function, we apply it to the first range of numbers. Okay, let's see like that. Okay, let me show you. Okay, so this means, you see this range of number 58, 98, 2, it means 98 maps to 50, 99 map to 51. Okay, fantastic. Now we don't want, now we want to turn these pairs to rules. So let me do another thing. Okay, let me show you. So you'll see, okay, capital, rule is capital. Okay, so the rule thing is basically Wolfram's notation to specify a pair. Okay, wait, what? Rule, yeah, so okay, so actually, so rule, you have the left hand side and right hand side. It simply specifies a pair. Okay, meaning that the left hand side transforms to the right hand side. Okay, so that's what this rule function means in Wolfram language. In other words, Wolfram language has a syntax to specify one single pair. It needs not to be part of the syntax of dictionary or part of the syntax of hash table. It has by itself a syntax to specify, left hand side, right hand side a pair. Then if you have a list of rules, that means that becomes a hash table basically. Okay, that's what these rules do. So but something is not working here, because let's try it again. There it is. So now you see, now you can see it shows the arrow. That means like a pair. Okay, so in a similar way, we can do this to the second range. The second is a lot more. So let's try it here. Copy and paste. So you can see a list of transformation pairs, a map. Okay. So basically now we got the function to apply to each of these range of rules. Okay. Now we just applied them to all. Then that get us these many maps as a hash table. Okay. So let me see. Okay, so actually we don't need to. Let's see if that works. No. Okay. So we got a list of pairs. Now, is there a simple way to turn this list of pairs into association without us applying the rules? Let's see. You see, once you got a bunch of list of rules, you need to turn that into a hash table. Yeah, but yeah, okay, so we all you have to do is you okay, yeah, okay, like this. Okay, so where's our code? Copy, paste. This is our code. Run it. So now here is the actual hash table. Okay. So this this code, let's make it one line. One line would be incomprehensible. I see. Okay, so let's remove that. Okay, so now we got this function that turns a list of ranges into an actual hash table. Now we just apply it to all of these maps. Okay, let me show you the power of Wolfram language. Okay, map you've never seen in your life in any programming language. Okay, so map takes 2 arguments or 3. So the first argument is the function. So here is our function. Okay, the function. Okay, here is our function. You see this function. Okay, maybe you don't understand. Let me rewrite these codes into a form you understand. Okay, so function x. Okay, so let me rewrite this code so you understand. Okay, so that's basically it. So function takes 1 argument, x, and the function body is this thing. So we take x, the argument, the second part, then the second part plus the third part minus 1, get a range, then transpose them, so you got pairs, a list of pairs. Then you replace the list of pairs by the rule, then you got this arrow thing, meaning a pair. Then you put association function to the whole thing, then it becomes actual hash table, okay? So it's a simpler way. I mean, over here, so this part and this part are equivalent. It just shorter, the first part is I'm using this cryptic shorter syntax and the pound sign. But okay, so anyway, so here's our function. Map this function to list. Okay, the list is maps, okay, which is, this a bunch of maps of maps. Okay, we want to map them to level 2. Okay, we want to map, so the maps is a list of list. Okay, so you do you understand? So we want to map it to level 2. Let me just show you. Okay, so map there. Okay, shortest code possible. So you see, now you got, what you got is all the maps. So we got the list of hash tables. That's the first one. Then after you map this, then you got the second association. Okay, then you got the third one. Then you got the third one has like 3 range of maps. You see 3 of them. The third. So this is the first part, first range of things. This is the second range of things. This is the third range of things. And together that's a third map. You can see here. You see that's a soil to fertilizer, and so on. So now we got a whole bunch. Now there's one more thing we need to do. We need to merge this map. For example, let's look at the first one. So the first one is got 2 lists, 2 ranges. Okay, so once we do the conversion, we got 2 hash table, 2 dictionaries. So this is the first one, very short. This is the second one. We need to merge them. Okay, so we all we have to do is just okay, so let's do one more step. Okay, so you map again. Yeah, what happened? Okay, so you just map again. Now this time you want to merge 2 associations. Okay, you are given a list of associations. You want to merge them into one single association. So from list of hash table to one single hash table. Okay, let's do it. But what is the function? I don't remember. Okay, so well, look up the XR Wolfram tutorial. Okay, XR Wolfram language tutorial. Association. Define a function, data structure, association list. Okay, then you have get value, add key, delete by key, check by key existence, association to list, association filter, miscellaneous. Okay, map to values, apply to keys, functions that applies to keys, functions operating on list of association. There, key union. That's what you want, key union. So what this function do is that taken 2 dictionaries, it will merge them into a single. Okay, key union generate a list of associations in which each association has a union of the keys of the association 1, 2, 3, 4, and so on. Padding by inserting values missing if necessary. What? What do you mean missing if necessary? Let's just try it, okay? Let's just try it. For example, let's see. The first one is there overlap. 98, 99. There it is. Wait. 98, 99. No, there's no overlap. Okay, let's try the second one. 98, 99. Then here's 52, 97. There's no overlap. 52, 97 and 98 to 91. Okay, the second one, there's no overlap. You see, now the third one, soil fertilizer to map. Let's see. 15 to 51, 52 to 53, then 0 to 14. Oh, no overlap. It's actually quite adjacent. What a tricky fuck. Let's see the third one. I mean the next one. So now it's fertilizer to water map. 53 to 60. 11 to 52. Oh, adjacent. Then wait, 11 to 52, then 0 to 42. There it is. Overlapped. Wait, 0 to 6. No. Okay, 0 to 6. Then 7 to 10. No overlap. Amazing. Okay, let's look at the next one. 18 to 24, 25 to 94. Oh, amazing. No overlap. Then next one. 17 to 77 to 67. 45 to 63. Wait, 77 to 99. 45 to 63. 64 to 80. Amazing. Oh, wait. Oh, there it is. Overlap. You see? It's tricky. Fuck. I knew it. You see? This one. Wait. So this one. Light to temperature map. You see, you got a 77 to 45, then 77 appears here again. Wait, what? 77 to 99, 45 to 63, 64 to 76. Oh, wait. No overlap. Okay. Oh, interesting. No overlap. Okay. So next one, we wanna double check this because it's kind of actually it's not important. I can just actually merge them, but I wanna double check. 68. Okay, no overlap. 56 to 92, 93 to 96. Okay, actually there's no overlap at all, but I want to merge them anyway. Okay, so we cannot, there's no example that we can use right away, but let's do it. what is the okay, let's see what this returns. So here is trying to see what it actually returns. Key union. Wait, it doesn't merge. Key union generate a list of associations in which each association has a union of keys. What? Oh, okay. It makes sure that every association has the same set of keys. Yeah, it makes sure. Yeah, that's what it does. Okay, that's not what we want. Union is what we want. Okay, let's try union, not key union. Okay, actually I'm spending more time than necessary. Union, yeah, you need to get rid of the okay. There it is. So union is the function you want. Union, you want to merge associations. So in this case, you just do a map, okay? Map, okay? The first function is, let's put that there. The first function is union the whole thing. Okay, okay, let me write the way it's easier to understand. Okay. This way it's easier to understand. The list is whatever output of that. Okay, so okay, let me show you. So we define this bunch of maps, but now we merge them, so it's more proper. Okay, let me show you. There it is, union. So now you see this list got how many items? Basically 1, 2, 3, 4, 5, 6, 7, 8. Basically the number of maps, they are all merged, so you no longer have separate ranges. So this one is, for example, this one is 98, so it's not sorted. We can actually sort them. But anyway, I think you guys know what I mean. I'm kind of getting too slow now. It's 1 hour. Shit. Too much explanation. Okay. Okay, need to finish this quickly. Okay, here is kind of explanation code. Map 3 equals to that. Okay. And here is explanation code. Let's put the explanation code here. That's for those of you learning Wolfram language. Okay. And so now, and let's put that explanation code here. Okay, so now our function is very simple. Okay, let's see, copy, 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 copy. Okay, now select all, paste. So now this is our code, entire code. Okay, now run it. So it just basically output this huge association. Okay, now I'm ready to do the. Okay, so now given a seed, now the problem is given a seed 79, what is the final association number? Okay, so what you do is you want to go through map 3. So let's see. So you got a list of associations. So you use the first one. So you got a list of dictionaries. You have a number. You want to feed the number to the first dictionary, get a value, then feed it to the second dictionary, get a value, and feed it to the third one, get a value, and so on. Okay, so you can use reduce. That's right. In Wolfram language, that's called fold. Okay, let me show you. Okay, so fold in Python and JavaScript, it's called reduce. Okay, so fold takes two things, a function and a list. Okay, the list is going to be map 3. Okay, which is a list of associations. The function is going to be, let's write 1. Okay, let's write 1. Okay, function takes x. So the function, and also let's add another argument, 79 to begin with. Okay, so what is the function? The function is, so you take the function will take two arguments, so x and y. Okay, and the first element is the x, it's a number. You want to apply the association, so what you do is the y is association, association of x. So that x is the key. That's right. Yes, you get a key. So you want to know the value of a key in an association. So the key is x, the association is y, then you get a value. For example, let's try it out. Okay, so for example, 78, for example, 79. Okay, then what is the association? Let's see the first one. Okay, copy it. So you got association here, then association at 79, which should be 81. You see, there it is. It should be 81. So let's evaluate that. Okay, you can see this part is association, and this is the key. You want to know what value is that. Fuck. This syntax works only if the keys are strings. Okay, but in our case, the keys are not strings. So what you have to do is you have to say key. Okay, evaluate it. There it is, 81. Okay, in Wolfram language, the key of association or dictionary or hash table can be any expression. Typically, it's in Python or JavaScript. Usually it's a string. In some languages, it could be any object, which is true for Python, I believe, but not for JavaScript, I think. But anyway, so in Wolfram language, then a key can be any expression. But if that's the case, then you need to say key instead of just you need to say key 79. Okay. So anyway, that is what this function do here. Okay, so let's do it. I believe that's it. We should get a bunch of we should get the final value for 79 going through these maps. So let me double check. You have a key, you use association second argument, that returns a value, and that becomes a key again for the next association. That's right. Evaluate it. Oh, fuck. Fuck. Oh, okay. So if the result is missing, that means after you go through all these maps, as soon as it's missing, you see one of the problem specification is that if it's not there, then simply return the same ID. So we have to add a condition here. So let's, don't, as soon as you find the key is not in association, you just return the same value. Okay, so that way, okay, we can do that. How do you do that? Well, there is, you see, in the association, let's see, association get value. So we were using this syntax to get a value, but there's a better syntax, more clear, is lookup. Okay, so when you do lookup, you call the lookup function, two arguments, association and the key, and you can supply a third argument, which is default. That means if the key is not there, that's the value you get. Okay, so let's use this syntax instead of this. Okay, so let me show you. So copy that. So instead of this complicated thing, let's put this here. Lookup, Y is association, X is a key, and the default value is X. Okay, it's not there, just return X. Okay, so now we don't need this function anymore. So let's try this again. There it is. So somewhere in these dictionaries it stopped. You just end up with 84. So let's check. Blah, blah, blah. What does it say? Does it say 84? What? C79, soil 81, fertilizer 81, water 81, light 74, temperature 78, humidity 78, location 82. Okay, we got something wrong. What? 71. Jesus. Shit. God. It's over an hour and we are stuck. Seed 79, soil 81. Let's see. This is our list. Okay, this is. Let me try to sort this. See if that works. I want to sort by key. Okay, no, sort by key doesn't work. You need to sort association. Yeah. What? What is a function to sort an association? So you check miscellaneous key sort. Okay, so you got key sort. Yeah, okay, so let's do key sort. Okay, so there it is. Now it's better, so 50. So this is the first map. You have 50 to 51. Let's check the original input. 52. Wait, you have 48 of them, which is kind of 98, 97, 98. Then you have 98, two of them, 98 to 99. That's right. So let's apply a key sort somewhere in our code so we get better understanding. Key sort, okay. So let's just put here key sort, okay. There it is. Now you have to do is do this. Now you see this is, oh, you need to sort after you merge them. Okay, after you merge the range. Okay, so not there. So you union, then key sort. Okay, let's apply that. Let's see if that, okay, you need a paren. Okay, actually do it better this way. You see, so the first thing is 50 to 99. There. The second thing is 50 to 99. What? The same? Oh, wait, we got that repeated shit. You see? Our input, we fucked up. Oh, that's why we are wrong. You see, we got it. Let's see the original. Yeah, we gotta repeat it. Idiotic. Okay, let's do it over again. So now we are better equipped. Select all, paste. So this is our whole code. Evaluate. So this is our first hash table, second hash table. The first is 50 to 99. The second is 0 to 53. Let's check 0 to 53. Okay, kind of makes sense. Yeah. 12, 13, 14, 15, 16. Yeah. The third one is, okay, it kind of works. Okay, now let's just get the code to, our actual code. Okay, so that's, what does 79 get you? 82. Let's go back here. 82, correct? Now, what does 14 get you? 43, correct? What does 55 get you? Let's just map them one shot, okay? So we got this function, then we just, this is argument. I'm just going to start to use shortcuts, okay, because that way it's faster. Okay, map to what, seeds, okay, seeds or seeds, okay, so 82, 43, 86, 35. Okay, 82, 43, 86, 35. 82 check, 43 check, 86 check, 35 check. Check the fuck of you. Okay, that's our code. We don't need this. This is for explanation. Put it here. So our code is basically we solved it, and now let's get our only personal input. Oh my god! Now we need to turn this into shit. Okay, so let's go back here, create a new file, save it as xadvent 2003 day 4 text. Okay, yeah, and we need to parse it. We cannot, there's too much to process manually. Okay, yeah. Okay, copy that, close it. Now the input, which is make a backup. Let's go back here, and showing what? Showing browser. So you see, this is what we have so far. Now show the Wolfram code. Now we need to input. Okay, input equals to something. Okay, so here's the file path. Input equals to read string. Okay, this is our personal input, but let's don't use that for now. Let's use the his toy input. Copy it. Okay, so the input is a, yeah, god, we need to parse this. Okay, we can do that. Greetings from Russia. What are you doing? It's very cool. Keep the good work. Thank you. I need those comments, okay, because I would appreciate those people who actually are watching what I'm doing, you know, doing this instead of the random comments. Okay, so there's a question, rule at. Let me explain that. Okay, so in Wolfram language, when you have, let me explain. Okay, when you have x at x, that is equivalent to f bracket x. Okay, now when you have x, when you have something at x, that means replace the head of x by f. Okay, let me show you. Okay, so for example, okay, so that means that is equals to that. Okay, when you have double at, which is a shortcut for the function apply, essentially what effectively it does is that it just replaces the x by f. Okay, for example, let's run it. You see, now if you have f at x, what that means, okay, this is getting complicated. What that means is that you apply same thing like double at, but you apply to the least each element. So it's this. So for example, let's see, x2. For example, this will become Okay, so you see that's what add means. So let's evaluate it. You see, so it becomes that. Is it complicated? Not really. But, like you just have to, because it makes very good sense to me. One add, two add, three add. So one add. Remember, one add is just a shortcut prefix syntax for the bracket. To add is a shortcut for the apply function. You can look up documentation, apply. 3x is the shortcut for apply add. Okay, you can see all of them. Now if you go to my Wolfram tutorial, you can see the entire this list of the entire these shortcut abbreviations by searching for Wolfram tutorial, symbols, principles, full form syntax there, syntax. Okay, I explained the whole thing. Okay, and so now you are here, you can just search for triple add, or you can see here, there, you see. So triple add is just a shortcut for apply, but with the option at level 1. That means you apply not just at the function head, but you apply the level. Okay, very simple. Okay, anyway, I need a break. I need to go to the bathroom. Fuck, because we are already 80 minutes, so we need to. Now the problem is to pass this input. Yeah, that can be easily done. Let me try to quickly do it. Okay, so first of all, let's get the input. Let me just show you what we are doing. I hope today it's, although it takes a long time, but it's all clear. So here's the input. It's just a text file, right? We want to pass this into a list like that. Okay, none of the English wordy map fuck. Okay, so how do you do it? Okay, so let me do it. So input, so you string split. Okay, first of all you split by, what do you want to split by? You want to split by, oh god, this is tedious fuck. Okay, yeah, but we have to do it because otherwise our the user's input, actually I can manually transform this to the list. Actually, it won't take too long actually. Let's just do it. Okay, let's just do it manually. Fuck the event of code. Because let me complain this. Let me make a complaint. If you try to be like logical, do a good job, the input's supposed to be, it doesn't say it's supposed to be a string or not. Okay, so but if you try to be fair, like in a programming competition, okay, you are not supposed to like manually fix the input, then run your code. You're supposed to assume the input is a text file, you do the parsing, okay, then it runs. So it doesn't matter whatever input, as long as it's in the same format, your code works. But the thing about event is that it doesn't care. It doesn't say what's the input or not. All it cares is what's the answer. Okay, so right now we are facing with a choice. We can write a parser. It's actually pretty trivial too, but it's tedious because you have to remove the first line, that's a seed, then you pass by this map word, to create this, So, but alternatively, you just fucking grab this, and with the power of Emacs, you just turn this whole thing into a Wolfram language input, right? Let's just do that. Fuck the advent of code, okay? I despise these sloppy fucks. Yeah, so this Emacs, let's just turn the whole thing into the, first of all, let's turn this, we already did this before, in fact. This sequence into yeah, so let's put a comma there first. Okay, let's do the whole thing, do it all. Okay, don't ask me, do it all, don't ask me questions. Okay, then for each one you just need bracket, that's a seed. Okay, then this one, what is supposed to be? Each line. Oh, okay, so it should be a line. So okay, the Emax power of keyboard macro, let me show you. Okay, so start record, do that, and record. Then select this thing, apply. Fantastic. Okay, then select this, apply. Wait, what? Wait. Select this, apply to each line. Fantastic. Okay, select this, apply to each line. Fantastic. Fuck the admin of code. Okay, do it. Yeah, still tedious. We can make a macro of macro actually, but let's just stay simple now. Okay, so now you got all this. Okay, so now you, yeah, so you cut that. This is whole thing is a list. Okay, let's record another macro. Nah, let's not. Cut. Okay, fertilizer my ass. Temperature my ass. Okay, let's double check there's no syntax errors. Okay, and this part, add a bracket, add a bracket. Okay, so in fact, double check, let's double check we correct, make sure no syntax error. That's right, that's right, remove that, that's right, remove that, that's right. Okay, now we just put the whole thing into a list. Okay, okay, now the whole thing is a list. Okay, that's right, go down here. Oh, then you need a comma there. Okay, comma, 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 comma. Okay, so that's it. Cut the whole thing, undo, back to my Wolfram code, and oh yeah, the maps. Okay, so maps equals to that. Okay, so basically that's it. Let's try it again. Okay, we have new seed. It's so we got the maps. No, that's the old maps. So this is the new. So the new is that. Okay, copy. Let's see if we got the syntax error or not. Select all, paste, and evaluate. fantastic. So we got seeds, we got maps, bunch of maps, and here's the output, which is correct syntax. Is there any null in it? Because if there's a null, that means we got extra comma or missing comma or something. No, there's no rule. So there it is. Okay, now here's our solution. Copy that, paste, do it. Why is it taking so long? Okay, shit. It's pretty bad. So what happened is that when I started to run that Wolfram code, the Wolfram code probably something wrong. So it ate up all the memory and my computer froze. So it ate up all the memory and I have problems bringing up the task manager. It basically froze my computer. Eventually I was able to abort the computation, but apparently it also fucked up the OBS. So OBS stopped streaming the video. Yeah, so but I didn't know the video is not back. I thought everything is still going. So okay, so everything is good now. Fuck. So what I'm trying to do, I just restart Wolfram language and I'm double checking my input. You know, we manually crafted the input. You know, the input is supposed to be this, you know, text file, but we manually try to convert it to the Wolfram language syntax like so. But possibly there's some syntax error, you know, some structure error. The syntax is still valid, but however, I'm missing a curly braces or something. That is why Wolfram language, you know, the code got the wrong structure. So maybe that is why it's eating all the memory. So right now I'm double checking if our, you know, the input is correct. So I'm checking, you know, this is our input. The length is 7. That's correct because it corresponds to 7 of these input dictionary hash table. And we double check so we can use shallow level 4, depth level 4 to see all the triples. Each triple is a range. So it seems all correct. Okay, so now we can try our code again and hope that it doesn't crash. You know, it seems correct to me. It seems correct. Okay, let's do this. Okay, so copy the seed away. Let's put the seed here. Let's redo the toy input. Okay, so that is a toy input, and let's see the toy input. Yeah, it's all 3. That's correct. Okay, so the toy input and our solution is just these 3 lines of code. We have not tried to shorten it yet, but it can be just one single line. But let's see. What? Oh, there's a solution. 82438635. 8243A635. That's correct. So it works on the toy input. Now we just need to try the real input. Okay, so maybe this shouldn't use up gigabytes of memory. So I don't know what is going on really. So now let's try the real input. Okay, so the real input is, let's see, seeds. So that's the total input. So here is the real input, and we can actually copy the whole thing. Okay, let's just select all. Let's open a new window, paste it, increase the font, double check. So this is the beginning of our real input and maps. Okay, then just run the whole thing, and let's hope it doesn't crash. If it does, that's no good, because we're gonna stuck for another 10 minutes or so. But it shouldn't. Okay, I don't know why it was crashing before. It shouldn't. Run it. Okay, let's go back to monitor. Memory. Okay, it's sucking up memory. Now something. Is the video back? Okay, so Nineberry. Hey Nineberry, do I know you? Looks like you are someone I know. Okay, so but is my voice all this while going? So what happened? So do you guys know what's wrong? What happened is that each of these three numbers. No, the problem is not about missing comma. There's no missing comma. The problem is that each of these three numbers represent a range of values. So, but there are a huge number of them. For example, this one, there are 124 millions of it. The second range, there's 105 millions of it. The third one is 278 millions. So for each one of these, we are creating an array. In fact, we are creating two arrays. Each one is, these few millions of entries. Then there are hundreds of these. So obviously that's memory is gonna map out. So that is a problem. The problem is that we do not want to literally create a dictionary. Instead, we should, for each of these three numbers that specify a range, we should just turn these three numbers into two pairs of pairs, 4 numbers total. So the number will be the beginning and end of the source ID and the beginning and end of the destination ID. Okay, so once we are given an ID, all we have to do is we check if it's in the range of source ID. If it is, then we find out what number it is in a destination ID just by counting the index. So that is how. So instead of a hash table, we use just that, beginning and end of the range. So it's a tricky problem, kind of. I didn't, you should have thought of how large this number is, a few hundred millions. But now I'm getting tired. It's over 2 hours. So to solve this, it's still easy. I mean, it'll take another 20 minutes, 10. Ideally it'll take just 5 minutes, but when you actually do it, maybe 10 or 20 minutes. But I'm tired. So I think that's it for today. So far, do you guys understand what I'm saying? What was the problem? Why is it the memory crash? It's all understood. So we just need to change this algorithm. Okay, so but I think that's it for today. We tried, we didn't finish, we didn't get it. Okay, that's all right. I'll finish it offline. Then tomorrow maybe day 6. We're just gonna push on. Okay, so thank you guys for watching. That's it for today. Bye guys. So let's see what is there anything going on in Discord? Okay, bye guys.